Friends, in this video we are going to learn about the cross product of the vectors. We call cross product as the vector product also. Here first we have to understand what is the cross product is. We can state the cross product as the vector which is equal to the product of the magnitude of the two vectors with the sine of the angle between them, and its direction is perpendicular to the plane in which the two vectors are lying. I repeat it. Cross product can be stated as the vector whose magnitude is equal to the product of the magnitudes of the two vectors and sine of the angle between them, and its direction is perpendicular to the direction of the vectors which are lying in the plane. Diagrammatically, you can understand this cross product very easily. For example, take two vectors. Say it is vector A, okay, and we got one more vector as the other vector. Let's say it's the vector A bar and it is B bar. To multiply them, we have to add their tail to tail. Here I am transposing the vector, okay, and the two have been added like this. Then we have to do the multiplication. The multiplication of the vectors is very easy. If it is A bar and it's the B bar, the vector multiplication A bar cross B bar is equal to C bar. It's simple. Simply we can write it as A bar cross B bar is equal to C bar. And also the magnitude can be had as modulus of A bar cross B bar is equal to AB sine theta, already I told you, into n cap. N cap gives the direction of the vector. See this, A bar cross B bar is equal to AB sine theta into n cap. But every time we mention the direction, and how can we get the direction of the resultant vectors is the important thing. But it is easy to know the direction. To know about the direction, you must know the right hand rule. By using the right hand rule, you can find out the direction of the resultant vector of these two vectors A and B. Here it is the right hand, okay. Here we know that is the thumb and these are the finger. We can curl the fingers like this. The fingers can be curled like this. Is the key point to know the direction of the resultant of the two vectors which are lying in the same plane. Here just go towards and keep your right palm over the vector from which we have to move. That means we are multiplying A with B. You have to keep your palm on the first vector. See this. Here you should not keep in this way. That means what could happen? The rotation of the fingers goes in this way. That means you are getting the larger angle. All the time you have to take the smaller angle between the two. So I am keeping the arm like this, and now see this, I kept, and I am moving towards the B vector like this. Okay, I am curling my fingers. I hope you understood. We have to keep the palm on the first vector Okay, here we are multiplying A with B. Then slowly curl your fingers towards the second vector. Here, we curled it. It's the direction in which we moved. I hope you are understanding. If you watch it closely, you will find that this is the direction of the vector and thumb is going in. It means that the resultant of these two vectors, A and B, will be into the plane. That means into the plane is shown with a cross. I will explain why we are taking the cross. Let's say it is an arrow. Okay, and you know that an arrow has the tip and as well as the tail. A tip and as well as a tail. If I turn this arrow in this way, this tip appears to be like a dot, and I do the same. I take this way, it appears to be cross. Generally, what an arrow is drawn like this. Maybe you are playing dot. Here it is a tip and it is the tail. Okay, when we are representing the tail, we have to go with a cross, and if we put a dot here, it is a tip. It is tip of the arrow and it is the tail of the arrow. I hope you are understanding. That's why I put a cross here. Here I am rotating the fingers like this. I am curling the fingers. It is moving towards the B vector. That means what? It is into the plane. Okay, if it is A bar cross B bar is equal to C bar. And what is the direction? Direction is into the plane. Okay, it is the first thing we have to understand. In this way, you can find out the direction. And now I am doing one more thing. I am doing the same here. I took the same vector. I kept them like this. It's the vector A and it's the vector B. Now I am moving. I am multiplying B with A. Moving means multiplying. Here I have to keep the palm like this. Okay, and you have to curl your fingers for a smaller angle. Okay, this is the angle which is equal to theta. Okay, and we have to get the cross product. B bar cross A bar. And what could be the direction? What's this? The tip of the arrow is out of the plane. Then I have to write it as okay. See, it's the tip I showed. I'm representing same here with a larger diagram. It's a vector A bar and it is B bar. Okay, I'm moving. That means multiplying B with A. See this? I have to take a smaller angle. I'm curling the fingers. Then if you watch the thumb, it is out of the plane. It is dot. Then you can write B bar cross A bar is equal to C bar. But see, the direction has been changed. I have to write it as minus C bar. Here, the resultant C bar is out of plane. Out of plane. And here, C bar is into the plane. It is the way to find out the direction of the two vectors which are multiplied in cross product method or vector product method. Now we are going to learn about few examples of the cross product. I already told you how can you find out the direction. This is the key point. Okay, if the thumb is into the plane, that means it is shown by arrow, and out of the plane it is shown by tip of the arrow. Now we are going to learn few examples of cross product. The first example of the cross product is what? The torque is a torque. Torque is the best example for the cross product. Now we are going to learn about the examples of cross product of the two vectors. The first and important example is what? The cross product between perpendicular distance and as well as the force. Okay, and you know that the magnitude of the torque can be had as tau is equal to RF sine theta. That's why I told you it's the magnitude of the product of the two vectors with the sine of the angle between them. And one more example, it is often used in mechanics. V bar, okay, is equal to R omega sine theta. That means the form of the equation is V bar is equal to omega bar cos R bar. Here's one more example of cross product. Then after we will take some properties of the vector product. The first property is vector product of two vector is anti-commutative. Here it can be represented like this: a bar cross B bar is not equal to B bar cross A bar. You know that when we multiplied B vector with the A vector, we got the resultant as minus C bar, and here C bar. It means what? It is anti-commutative. Okay, and second one, here we are taking the two vectors, a bar and one more A. We are multiplying the vector by its own, a bar cross A bar. What we yield? Here you know that A bar cross B bar is equal to AB sine theta. A bar cross A bar is equal to A into sine theta. You watch it carefully. The angle between A to A is equal to 0. That means it is equal to 0. That means what? The cross product of same vectors is always leads to a null vector or zero vector. And one more thing, here two vectors are perpendicular to each other. That means 0. Here we are taking them as perpendicular, A bar cross A bar. Here actually we are taking the magnitudes is equal to A into A. That's what we get. Okay, and say the angle is 0. Here we are taking perpendicular. That means A into sine 90 is equal to A squared. Similarly, A bar cross B bar, when they are perpendicular to each other, is equal to AB. And one more thing, okay, if theta, angle between the vectors, is equal to 0, already we got, it is equal to 180, then what we get? The magnitude of two vectors, A bar cross A bar, is equal to A, I take it as the B, AB sine 180, again 0. That means what? Whether two vectors are parallel or anti-parallel, okay, the cross product of the two vectors is 0. They are perpendicular. The cross product is maximum. These are the few properties of vectors. Then after we will learn about orthogonal vectors. That means multiplication of orthogonal vectors, the unit vectors. Okay, we are taking the unit vectors. As you know that, what is a unit vector? The vector whose magnitude is 1. But here we are taking the orthogonal triads. Here we represent them as is I cap along x-axis. If it is y-axis, then the unit vector along y-axis is j cap, and along z-axis it is k cap. Okay, we have to go with vector multiplication of the unit vectors. Vector multiplication of unit vectors. Okay, we are using the basic property. What? A bar cross b bar is equal to AB sine theta. If you watch this diagram carefully, the angle between I and J is equal to 90, J and K is 90 again, and K to I, it is also 90 degree. Okay, when we take the orthogonal vectors, the angle between the two vectors itself 90. Now we are multiplying I into J. Okay, here first one, multiplying I cap into J cap. We need to find out the magnitude. It is equal to Ij sine 90. Okay, as you know that sine 90 is equal to 1 unit vectors. 1 into 1 is equal to 1. Similarly, if you go with J cross K, and you will get the same result. It is J into K into sine 90. It is equal to 1 again. And similarly, if you go with K cross I, then it is equal to Ki into sine 90. Again it is 1. What does it mean? What? I bar cross I bar is equal to J bar cross J bar is equal to K bar cross K bar is equal to 1. If the vectors, it means when the unit vectors are here, what we can write here, I bar cross J bar is equal to J bar cross K bar is equal to K bar cross I bar is equal to 1. is the needed result. Okay, then after we have to find the direction of that. It can be done very easily. Now we are doing the vector multiplication of unit vectors, and we will learn how to find the direction of that. To do so, I am taking two vectors. Let's say is the vector I cap unit vector side set, and I have one more vector. It is j cap, and I got k cap. Okay, see, I'm taking a cyclic order. Say this: if the two vectors are multiplied in it is anti-clockwise direction, the resultant vector is positive. That is what I bar cross j bar. See, they have been multiplied in anti-clockwise direction. I into j is equal to k cap. It's over. Then after we are multiplying j with k is equal to j into k, but to get I. And similarly, k cross I is equal to k cross I is equal to j. That means what? When the two vectors are multiplied in clockwise direction, anti-clockwise direction, then the product is positive. The resultant vector is positive. We are doing the same thing here. It is I cap, again it is the j cap, and it is k cap. Now we are taking clockwise direction. See what happens to this if you go with the clockwise direction. I bar cross k bar. Okay, we are going in clockwise, and what could be the result? We have to yield this, these two are multiplied, and we'll get minus j cap. I said when it is in clockwise direction you have to take negative. Then after we are multiplying k cap to j cap, what you get? Minus I cap, and similarly j cap cross I cap. We'll get k cap. Together we can write I cap cross j cap is equal to k cap, and j cap cross I cap is equal to minus k cap. Okay, and go with this. J cap cross k cap is equal to I cap, and k cap cross j cap is equal to minus I cap. And third one, k cap cross I cap is equal to j cap, and okay, I cap cross k cap is equal to minus j cap. That means what? If you multiply them in anti-clockwise direction, the resultant will be, that means resultant vector is a positive one. it is in clockwise, then it will be negative. Vector cross product can be stated as it is the magnitude of the vector which is equal to the magnitude of the products of the two vectors with the sign of the angle between them, and the direction of the vector is perpendicular to the plane in which the two vectors are containing. Let's take those two vectors which are in a plane as A vector and as well as the B vector. We have to take the rectangular components, means ax I cap plus ay j cap plus az k cap, and also bx I cap plus by j cap plus bz k cap. Here we have to call back our memories. We multiplied unit vectors in two different ways. When we took the vectors like this, I, j and k, okay, we multiplied them in clockwise and also in anti-clockwise. When they are in anti-clockwise, we took the product as the positive, and the same thing we applied I, j, and by taking k, then we went in clockwise. We took it as the minus and we multiplied the vectors like this. I cap cross j cap is equal to k cap, and j cap cross k cap is equal to I cap, and k cap cross I cap is equal to j cap. Here if you go in this way, we get I cap cross k cap is equal to minus j cap, okay, and k cap cross j cap is equal to minus I cap. See, they are just mirror reflections, and j cap cross I cap is equal to minus k cap. Here, see, okay, and we watch it carefully, this one, and it is here. In such way we did the multiplication. Now we are multiplying by taking these two. That means what? A bar cross b bar is equal to ax I cap plus ay j cap plus az k cap multiplied with bx I cap plus by j cap plus bz k cap. This is the multiplication, and we go further. Now we are multiplying these vectors. I am writing it as ax bx multiplied with I cap cross I cap, okay, and you have learned that I cap cross I cap is equal to j cap cross j cap is equal to magnitudes we are taking is equal to 0. Okay, since the angle between the two is equal to 0, and you learn that A bar cross B bar is equal to AB sine theta magnitudes. We are getting the same. In the place of A, we put A, and B, it is I again, and if you take the angle theta is equal to 0, then we'll get the 0. Then after AX BX is over I cap cross I cap, immediately it is 0. And then after we have to go with AX BY, okay, into I cap cross J cap. See, I cap cross J cap, I cap J cap, it is equal to K cap. Here what you have to write, IJ, okay, multiplied the I cap, okay, plus AX BY we multiplied, and AX BZ into I cap cross K cap, I cap cross K cap, we got it as minus J cap. The first term is over, then BY, AY BX into J cap cross I cap. See that J cap cross I cap, where it is equal to minus K cap plus AY BY J cap cross J cap, obviously it is 0, plus AY BZ AY BZ into J cap cross K cap. See, what is J cap cross K cap? It is I cap. And we have to go with the third term, that is we are taking AZ BX, okay, into K cap cross I cap, K cap cross I cap, it is J plus AZ BY into K cap cross J cap, K cap cross J cap, we got it as minus I, it is equal to minus I plus AZ BZ into K cap cross K cap, obviously it is 0, and we are taking these terms are 0, and we will write it as AX. First we have to write I terms, okay, it's I and it's I. Where is the I? It is the I, and we have I. What is that? AY BZ minus AZ BY, okay, into I cap. Say this is a plus and it's a minus, we subtracted, plus I term is over, and we have to go with the J. Where is J? Here's the J, and we have to search for the minus J, plus AZ BX minus ax bz into j cap plus we have to search for the k. Where is the k? Here is the k. Ax by minus here is the k. Ay b x to k. Okay, in this way you can find out the vector component, that is vector product of two rectangular components of vectors, that is a bar cross b bar. Here we have. Students, now we are going to do the determinant method. As you know that the vectors are taken as a bar as ax I cap plus ay j cap plus az k cap, and b bar is equal to bx I cap plus by j cap plus bz k cap. Okay, we have to write these vectors in a pattern in the determinant form I, j and k. That means we are writing in rows and as well as the columns. I represents with a j or y, z. Similarly bx, by and bz, and we have rows and as well as the columns in. Now take, we are locating the rows and as well as the columns, and we have to do the vector multiplication. It is equal to a bar cross b bar. First of all, what you have to do, see this, you have to mask this thing and this. Okay, we are masking jk and as well as the ax bx, and we are taking I term I. Okay, we masked j, the which one it is below the j and in front of the j I, it is j k and it is, we took the I and we have to multiply. See this, we are going in this way. These two are masked, that means we have ay bz, ay bz, okay, minus, okay, az, see, az by, plus, then we have to mask this j. That means we are masking this one and we are masking this one. Then what we get? Ik we have. Okay, Ik we have. Then put j cap here and multiply. This is eliminated. Az bx. Az bx. Okay. Minus ax bz. Ax bz, and what is the third term? K cap. This time we have to mask this and this, and you have to take the k. Okay, and take the first term as x, ax by, ax by, and ay bx. Okay, then it can be written as a bar cross b bar is equal to ay bz minus az by into I cap plus j cap into AZ BX minus AX BZ plus, okay, the second term I am writing J cap plus AX BY minus AY BX into K cap. The same result what we yield when we multiplied in another way. I think it is a better way to multiply the two vectors. Okay. It is the vector product of two rectangular, that means components of the vectors.